Hey there, I'm Alan Furstenberg.
And I'm Mark Tucker, and welcome to Two Voice Devs.
Two voice devs. How's it going, Mark?
It's going well. How about you?
It's been a week, but
Yeah,
it tends to be a week these days. So, lot of I've been doing a lot of work. Not all of it's very voice related, but a lot of other assorted stuff. So it's always good to be able to take some time out in the week and talk about voice or voice adjacent technology that we're playing with.
yeah. So I found myself like digging into docs and kind of tracking an issue, and it's related to voice, but it's not directly related to voice. It's kind of like right on the very edge, literally on the edge of voice. And I don't know. I thought maybe we can talk a little bit about it.
Sure. So what what
So,
what, what was the issue, or what did you solve?
all right. So typically, when I create Alexa skills, I host them in Lambda. It's there's a lot of reasons. It's easy to do, and it's cost effective, and there's some shortcuts that you can take
Yep. And
because you're talking, Alexa, Amazon directly to Lambda, and there's some shortcuts they can take because
yep.
they
And
all.
even now normally when you host in Lambda, you are running the Lambda yourself or using the Alexa hosted environment.
I have never hosted a skill in production from the hosted environment. It came
Okay.
out after
Yeah.
I started doing it,
Uh-huh.
and I guess I already have a workflow down that, and plus there are some limitations, um, and kind of like at some point in time, if you outgrow it, then you have to move it to a self-hosted anyway. So I'm like, I'll just self-hosted.
Makes sense.
So, but when you do that and you're not using Lambda, which means you're using some other technology or hosting this someplace else. It could be Docker. It could be I don't know. There's just a number of different ways that you can
Could
do
host
it.
it on
Your own,
Azure or Google Cloud
yeah.
or in
Any
an
of the cloud
on-prem environment
services,
or yeah.
a data center, your box at home, opening up a tunnel to the internet. I not recommended, but yeah, sure. You could host it anywhere. But there's a problem in the fact that you have an endpoint that is your Alexa skill, and you need to hit it with an HTTPS like post request. And how do you know that the request is coming from Amazon and only from Amazon?
Yep.
Uh,
That's
so
always that's a challenge, isn't it?
yeah, how do
Because
how do you do
well,
that?
and let's understand what the risks are if you don't.
Yeah,
Sure, you could say, well, nobody's going to find this webhook endpoint, and yet people do. And in some cases, depending on the reply, they'll if they start poking it and start getting back replies, they can figure out what is supposed to be there.
yeah,
If it looks like an Alexa like response, they're now going to be able to send you Alexa looking like requests, and you know they could do some they can do things from being very malicious to very exploitative depending on what your service is. So it's something we
yeah.
need to be very aware of.
Yeah, and if it's a hobby side project, you may not be so concerned, but if it's a client project or something that's has a person using account linking and linking to some other system or something, then you probably care a lot more. So, but you still have to solve this issue because you won't be able to submit your skill for certification until these different checks are made to make sure that yes, the web point is secure, and and everything's good there. So
That's interesting that they test it to make sure that it won't handle invalidly authorized requests. That's interesting.
yeah, there's a number of like when you go to certify it, there's like a pre-check, like a verification check that you can do.
Uh-huh.
And I hadn't really hit this before. I don't do a lot of non-Lambda hosted, self-hosted skills. So I hadn't really hit it before, and it seemed like it had passed the verification check, but then um, it got kicked back, and then when I tried it again, it actually gave me some errors, and the errors were indicating like we tried to access this insecurely, and your data came back, and you're like, oh, I don't have these checks in place, obviously.
That's
Then I had to
impressive.
go. Yeah, I had to go out and kind of check like what are the different ways that you can secure this, and so. There's a document online. It's officially titled, if you wanted to search for it, um, host a custom skill as a web service.
And we'll
And
post links to all of these documents in the notes below.
yeah, so what it's basically saying is that, all right, you've got a request coming from the Alexa service and it's hitting your webhook. And there's certain things, besides the payload being the JSON, that is your request, that includes your intent and all that stuff. There's other things as part of the request. There's headers um, that are happening, that are being passed, that you need to deal with. And so I'm not going to go through all of them, but like all the details. But the two things that you need to know is that the two headers is there's one called signature 256 and another one called signature cert chain URL. So
Now, it's interesting to me because tools like Dialogflow have the same needs. They
yeah,
need, again, anything that has a webhook like this in some way needs to validate that request. And Dialogflow provides a number of methods, some of which are, to be fair, pretty insecure. But one of the things they do support, though, is authenticating with a service identity token. And that token is sent as part of the authorization header, which is a standard HTTP header, and is a bearer token that is JWT encoded.
okay.
So it uses a standard encoding method. So it's interesting that Alexa chose to go with a different approach.
Yeah, so I'll go through kind of the approach, but at the very high level is that the URL that you pass is actually a URL to a certificate that Amazon provides, and it's dynamic. It could change. That part of the reason why it's being passed is because over time certificates expire, and you need to issue new certificates, and so.
And also, let's be clear, these certificates have a fairly short lifespan. We're talking minutes or hours here, not days, weeks, months, years. These are very short-term certificates.
So I haven't tested that part. I don't know. I haven't downloaded the certificate and to see what the lifespan of it is, but that I'll take your word for it for right now. I'll verify later. I guess the three key pieces is there's that URL, there is the actual string body of the JSON request that's coming in, and then there is a signature. So what happens is that before this request happens on the Alexa server, then the body is signed using the certificate, and the signature is sent along as well as the certificate. So that on our side, there's a number of checks
as well as the URL of the certificate.
As well as the URL of the certificate.
Right.
So what needs to happen on this other side is kind of like as soon as you receive the request in, then you need to do a number of checks. One, well, checks is that like it's got both of those headers, and that the certificate URL that you're being passed is a specific format. It's coming from a specific place from Amazon. And then you need to download the certificate, and you take the request body and you re-sign it, and then you compare the signatures to make sure that nobody tampered with the JSON that was being passed in as the body of the request.
Makes a lot of sense, and it's very secure. And the reason why that certificate rotates frequently is because there's always a concern about a replay attack. So if somehow if someone determines what packet has gone through, they can now easily recreate a new one and replay it. And to avoid that, one of the tricks is to have certificates rotated very frequently. Google does something very similar. So encoded in the JWT that's sent across is the location of Google certificate, some time frames when this packet should be accepted, this header should be accepted as valid, It also includes the identity of the project that it's for. So you can verify, yes, this is my project. This is really intended for me.
Okay.
And that's another additional step that you can go through to make sure this is really valid and intended for you. But otherwise, very similar concept. You've got a signature that comes in that you need to verify.
So part of the JSON request that's coming in is an application ID, which is the skill ID. Right. So you could do that check. It's not part of this check, but you could do an additional check to make sure that, and it's coming in for the expected skill that I'm dealing with. Mm-hmm. But also part of that JSON request is a timestamp, and that is actually the timestamp that's checked to see if it's within 150 seconds of the current time, and rejects it. So that prevents the replay, and the fact that you can't change that body without affecting the signature and thus invalidating the signature means that's so there's a possibility that the Amazon certificate could actually be for a longer time span because the date is signed inside of that signature, and so it's doing that additional check. But somehow you want to make sure that one, the contents isn't tampered with, and two, you're protected against replay are the two main concerns.
Okay, so we have JSON payload, we have a signature, we have a URL that gets for the certificate, and we've gotten the certificate. How do we do this? And we know roughly how to do this, but how do we actually do this?
Well, you could do it by yourself, but that's not recommended. There are libraries out there that handle that for you. And so on this particular project, I'm hosting the code is actually hosted in an Express.js server. So that's the thing that's actually exposing an endpoint, listening for specific endpoints, and then funneling that into some sort of a handler. And then at the very, very beginning of those handlers, then these different checks are done. So one approach would be to use something called the Alexa Verifier middleware. So there's a library called Alexa Verifier, and its job is to do those checks. It takes in the certificate URL, it downloads the certificate, it takes in the signature that you passed, and it takes in the request body and does all those different checks. And if it passes, then it moves on. If it fails, then it returns back like a 400 error or something.
I was going to ask what happens if it fails, and how is that supposed to be reported?
So any non-200 response coming back from that request kicks back to Amazon, and what the user ends up hearing is that there's been a problem with the endpoint or something like that.
Okay.
I don't know if it's like there's been a problem with the requested skills. No, I don't know. There's something that some generic message for a user, like I don't understand what's going on. But so that's one approach. Alexa Verifier middleware calling verifier, and the middleware part is part of Express.js. Express.js is like a pipeline. You can set up various things, middlewares that happen, and even before your handler gets hit. So that's one approach, and that's kind of the approach that I started looking at, and I discovered that there had been some changes. March of this year, there had been some changes to the recommendation or the requirements of these different checks, and Amazon changed the name of one of the headers. Instead of signature, it changed to signature 256 because it was doing a SHA-256 check now on the signature. Uh-huh. And so the fact that changed meant that this older
library no longer was checking the right
things. Didn't apply. It hadn't been updated. It's kind of funny because in the Amazon documentation, it says it's got like a set off on a yellow box. It says important with a warning triangle explanation point. if you currently validate the signature header against the SHA-1 hash of the HTTP request body, we recommend that you update your implementation to validate the signature 256 header against the SHA-256 hash of the HTTP request body. Now, they're no longer passing the signature header. So I guess it's recommended in the sense that if you want this to work, then yeah, go ahead and update to the signature 256 header. But it's just a recommendation. So it's required.
Okay, so if this library didn't work for you, what did you end up doing?
Well, I had to look around at other things. And so the thing that I came across, that I know that I do Jovo, and that's a lot of stuff that I do. And so in some cases that's a little different than a lot of the documentation that you get coming out of from Amazon, because their open source framework for doing this is the Alexa Skills Kit for Node.js version 2. And so I knew that they would have to have solved the same problem there. And so I started looking into it, and inside that same group of projects for the Alexa SDK, there is a project called Ask SDK Express Adapter. So it's an adapter that you can plug into Express that does these checks. Now, there's two different ways that you can use this library. And the first one didn't work for me, because the first one, it was overly helpful in the fact that it would take the request, but at the very end, it would just put you right into the pipeline for Alexa Skills Kit. So the fact that it wanted to jump into that framework, and I'm like, I don't want that framework. I want to use my Jovo stuff. So that didn't work. But if you're doing Alexa Skills Kit, then that's the approach that you could. But thank you, developers of this library, because they've also made a way that you could pull out just the two verifiers from the library, and you could use the verifiers in your own code. And so that's kind of the approach that I took. So I had to, in the handler for Express, then went ahead and added the verifiers. They've got them split up. So there's a verifier that actually does the check for the signature verification, and then there's another verifier for the timestamp.
Okay.
And so that actually worked. They created it so that you could use that in any web application. And so I just had to figure out, okay, after that succeeded, what do I need to then pass on to the code that was already there that would turn that request coming, that HTTP request coming in, into something that would feed into the Jovo framework pipeline.
Okay. So you needed to find a good way to front end the Jovo framework.
Yeah.
Sounds reasonable.
Yeah, sounds good. But it took a little while, and some experimenting, and I'm like, why is this not working? And I finally discovered that there was there has been a change to the signature header, and one of the libraries did not update yet.
That's that is in some ways the beauty of open source, but also the pain of open source.
Exactly.
The developer who did it may have moved on, and they don't need the code either way anymore.
Yeah.
So now what?
Yeah. Who keeps maintaining it?
Right. Who needed to know? Who should be paying attention when changes like this came down the pipeline?
Yeah, and it's like if you're not actively doing this, then you wouldn't have.
You would. Yeah.
It's not like Amazon reaches out and say, "Hey, I noticed that you're using."
SHA-1, you need to switch that to SHA-256.
Here, I'm going to find all the open source projects out there that are helping with this verification step, and I will notify you personally when these things change. That's the challenge of open source, is that sometimes libraries, APIs, whatever specifications change, and if you're built on top of that, then you need to make sure that you're updating.
Yep.
Over time.
So, but it sounds like you've successful gotten it working.
That part is working. There is some other environment issue that's my next blocker, but
okay.
Working
but
through
the authentication is working.
Yes, that authentication piece is working.
Okay. Anything else in particular on this chunk of code?
No, but when I said that this was like literally on the edge, it really is on the edge. It's the step that the very first thing that gets hit that checks to make sure that
Yep.
this is coming from Amazon. It's not directly voice. It's not like conversation flows. It's not the logic,
But
but it is.
without it, our webhooks for skills don't work.
Yeah, exactly. So sometimes you get to find yourself in particularly interesting places. We've talked about before, like we're doing something and this particular skill needs account linking. So now you find yourself in OAuth 2 land, trying to figure out all the different parts that you need to understand to get something, working successfully in that area too. So it's just kind of comes with the territory. But
Yep.
I'd be interested to hear what other people have encountered. That's, doesn't seem like it's directly involved with writing the voice experience that they're writing, but it's one of those things that has to happen.
Yep. And if you do have your thoughts on this, you can reach out to us at the usual locations, Twitter, LinkedIn, comments below. We'd love to hear your feedback. The bits that you've encountered, how have the skills that you've needed to learn elsewhere been brought into play to build skills that
your technical skills for building elective skills? Is that what you're saying?
Yeah.
Okay.
I never thought about that one before.
I understood that. I got you.
Yeah, okay. Anyway, we'd love to hear about it, and we will talk about it another time on Two Voice Devs.
Two Voice Devs. Take care.
Take care.